Okay, there we go. Make sure everything is testing, testing, 1, 2, 3. Okay, that should be good. Okay, everybody, welcome back to the final session. Although, depending on how far we get, I might be doing one more. It's just all going to depend on how far we get through this, as I did... Oh, I need to mute that. I did not run a session last week because of some reasons. So depending on how far we get, I might run one more next week, or I might just upload them as individual videos. Okay, so what are we going to be working on today? Well, actually, where did we leave off 2 weeks ago? We left off, we had a fully working player movement system where we could run around, and our players' stats would affect how fast we would move. We didn't have any code in for shooting. No, I think we do. Yeah, we do have some code in for shooting. And every time we click, we can damage ourselves. And the important thing about how the system is working is this entire system is all working through as disconnected as possible, so that there is no physical connection between the UI, the updates for the UI and the updates for the player. There's no physical connection. It's all through actions and events, which is the important thing. It helps keep our code separable. It helps keep our game also modular and interchangeable. So if I wanted to, I could take this character out of this game. The UI would still work, it wouldn't throw any errors, but nobody would be updating the UI itself. Or I can take the UI out and the character's fine on his own. There won't be any null reference errors or anything like that because the UI all of a sudden disappeared. So that's the importance and why we're doing it that way. It's a little bit more complicated, but once you get your head around it, it's pretty awesome. So today what we're going to do is we're going to start working on the zombie system itself. So we're going to do a little bit of setup in the world, and then we're going to jump into coding. So the first thing we need to set up in the world. The first thing we need to get set up in the world itself is I guess, yeah, let's go with that. Let's go with creating the zombie first, and we can jump on from there, because I can also show you how Unity's prefab system works. So if we right click in our hierarchy, as all of you should be familiar with now, we can go to 3D object and we can create another capsule. And this capsule will be our zombie. We can reset his position. So he's now on the floor. The player we can just drag back a little bit. So our zombie is a little bit in the floor here, so we're just going to raise him up by 1. Then we kind of want the zombie to be... we kind of want this capsule to be inside the zombie, because this is our model for our zombie, not the actual zombie itself. And we want to do it this way just to keep things separable, so that if later down the line we have a new model for our zombie, we don't have to change anything. We can just swap the model out as plug and play as possible. So just some things that we're going to need to make sure we have to just guarantee things will work correctly. We're going to delete the capsule collider from the zombie model. And then on the zombie itself, instead, we are going to add a capsule collider. We just have to update its height dimensions to 2 and then move the Y back up now. And the reason why we did that is, I'll explain the reason why we did that a little bit later. So we have a zombie now, but he needs some arms. So let's also just give him some quick little arms so he can attack us. Try to go through this really quickly. Just quickly give him some little sticks for arms. Forward. You guys should be pretty familiar with the now how to navigate and how to maneuver things around in Unity. So what we can do now is we want the other arm to be the same distance apart, so they're quite even. So what we can do is we can Control D to duplicate, like I showed you in the first session. But then what we can do is we can go over to the position up here. We can drag the X, and you can see the X is going up and down. The easiest way to get it identical, to mirror it, is to put a negative on it. And now you can see they're perfectly evenly spaced. It's a little bit hard to see. So let's go into our material where I have a zombie material created, and let's drag that onto the zombie. So now our zombie's a bit of a green thing. He needs a material for his arms. So what did I just do? Zombie create. So we're going to create a material for his arms. I probably clicked the wrong thing. Zombie arms. Now what we can do is we can set this to like a bit of a bloodish red color, or like a dark red. I want this material to be on both of his arms at the same time, but I don't want to have to drag here, then drag another one there. It takes a really long time, and when you have like a couple hundred things you're trying to apply the same material to, it can get a bit tedious. So instead what I can do is I can come into the hierarchy, select both the arms, these cubes for the arms, and then drag the arms into the inspector, and boop, now it applies it to both. Now you'll see that the zombie arms material is on both. So that's just a quick way of speeding things up. We're also going to remove the box colliders. We can speed that up by selecting both first and then removing the box collider from them. So now the only collider on the zombie at the moment is the one we added to the main zombie component. Cool. Very good. My headphones are telling me that my battery's low, but don't care. So now that we have our zombie in the world, what we want to do is we want to make a prefab of him. Because we would like to be able to spawn them in as much as we want or as little as we want. We would like some way of Unity remembering what this model, what this collection of game objects look like. To make it so that later, if we want, we don't have to rebuild him. We can just say, hey, Unity, make this again. And Unity does that through prefabs. So if we go into our assets, we can make a new folder just to keep things organized called prefab. Or prefabs, I should say. Prefabs. We're going to go into here. Let's make another one because I'm a little bit crazy with organization. Zombie. And now it's really simple to create one. All we do is we click on the main body. So if we hide everything, you can see everything goes in here. We click, drag, and just bring it into our asset folder. And now you can see in the bottom right, we have our little zombie capsule. And then if we want to make specific changes, we can just double click on this little arrow here. And then you can see everything goes white. And this just shows you what is currently in this prefab. And we can expand it to our capsule, his arms, and everything. And I can make changes to this, or I can double click this prefab and you can see now it's blue. I can make changes to this blue. Think of it like this version as a blueprint and think of the other one as like a live edit. But if I make changes to this blue prefab, so like say I take his arm and I move it all the way over here, once I save it and go back, now you can see the actual zombie in the world, his arm is over here. Because I've made changes to essentially the root model. So let's just see if I can undo that. No, I don't think that's possible. So we're just going to go ahead, copy this value, throw it back here. Boop, done. Save it again, and if I come out, you can see the zombie's fixed. So that's how Unity's prefabs works, and these are objects we can call upon later in case we want to do something called instantiation, in case we want Unity to create these models for us without having to rebuild them manually every single time. Cool. So now that our zombie's created, we can actually, yeah, we'll leave him here for a bit because we're going to need to put some scripts on it. So the first thing our zombie needs to be able to do is chase after our player. So let's get that up and running, why don't we? So if we go back, we close the materials, we close the prefabs, we don't need that. Back in our scripts folder, create a new folder called zombie. Oops, don't hold down shift while creating a folder. Okay, and then what we can do is we can create, so we have a player controller, we have a world controller, so it only makes sense that we call this zombie controller. Okay, and then we're going to open up Visual Studio. Oh, last time you guys wanted me to zoom in a little bit, I think like to about here. That should be good for you guys. Good. I am set to public. I hope I am. I hope I didn't make that mistake. Oh no, I'm on unlisted. Oops. Public. Oh, I am the dumb. There go my headphones. Well, that's a little bit unfortunate. Just give everybody a few seconds now that it's switched to public. Still a bit new to streaming like that. Okay, that should be good now. I suppose if people wanted to just, I mean, we haven't gone over much. We've just gone over creating prefabs, which can just be done by dragging any object from your hierarchy into your assets folder. But anyway, let me just double check the size of this on the stream. Make sure the font is big enough for you guys. Okay, that looks about what you guys wanted last time. Cool. Some of you might be watching on phones. Well, it looks like the audio is okay. I don't know what are you complaining about? Okay, let's get straight to it, shall we? So we need our little zombie that we've just created to walk around and chase after our player. So to do that, that's very simple, very easy, because what we have is what we essentially have, what we created in the first episode. If I can find it in our scenes, sample scene, Nav Mesh. Is we have our navigation mesh. It's in world, plane. Oh no. It's here. Navigation mesh. So all the way back in the first episode, we created this navigation mesh. Now it's time for our zombie to use it. And to use it, it's very simple. So what we do is we can go to our zombie, we can add a component, and we need to add a Nav Mesh Agent. And this tells Unity's engine, the Unity engine, that this is an entity that uses the Nav Mesh. Okay, and then what we can do is we can change its radius. So we want to set its its radius to 1, just to account for the arms. And this is to prevent the little capsule, the zombie, from accidentally clipping its face into a wall. So it just gives it a bit of an area, and like with your models that you want to use, you probably want to adjust the size so it best suits your model. within reason. I mean, it's okay every now and again for some attacks, like if you have an attack animation, for it to go through the wall. If it's not heavily going through the wall, like if it's extreme, then it might be a bit annoying for the user. Okay, so then what we're going to do is we need a Nav Mesh. We've got the Nav Mesh Agent, which is great. So now we pretty much have everything we can. Let's take our zombie script and throw it onto the zombie as well, and get straight into the coding. So we're going to just get rid of that because I always do that. We're going to need so the first kind of data we're going to need is a target, and this target we're going to need to be our player. So we're going to make a serialized field, which we're going to set to private, and then this is going to be our target. Hang on. This needs to be a transform. Come on. Our target. Then we are going to need a reference to the Nav Mesh Agent itself. Luckily enough, this Nav Mesh Agent is on the object itself, so we don't need to get it from anywhere else. So we're going to do nav... Oh, wait, hang on. In order to use the Nav Mesh Agent, I almost forgot, we have to use the Unity engine.ai package. Otherwise our code doesn't have any references to the required data, so private. Nav Mesh, Nav Mesh, come on, agent. There we go, and we're just going to call this agent. Okay, so then what we're going to do is we are going to need, to get access to a lot of our information. So we're going to do, a start function. Private, not rivet, private void start. Our private void start, what we're going to do is we're going to set our agent equals to get component. Remember, because our Nav Mesh Agent is on ourselves, so we don't need to import it from anywhere, we just have to look for it. So we go get component Nav Mesh Agent, tell it the type we're looking for. And that should return the first Nav Mesh Agent it finds, save it to agent, so that should be good. Then what we're going to do is we need to set our target. Now, we can run into an error here where if we tell it to move, because how we're going to be doing it is we are going to be telling our Nav Mesh Agent to move our zombie to a target. The problem is if there's no target, it can throw an error. So what we're going to do is we're going to do an if check for a target. If target is equal to null. Then what we want to do is we want to, if the target is equal to null, we want to find at least the player. Now, Unity has a tags, one of the tags that Unity has, I'm not sure if I covered this or not, but Unity has a tag system up here, and one of the tags that we can have is a player. So we can set our player and give it the player tag. This I would not recommend doing too much. This is just a failsafe in case we run into problems. Because what I'm about to do is very heavy, like very resource intensive on the Unity engine. So you only want to be doing this at least once. You don't really want to be doing it too often. So we're going to say target. So if our target is equal to null, if we have been lazy and we haven't set a target, or if we haven't set a target or just dragged and dropped them in, we're going to do game object dot find object. Now there's two. There's objects with tag and object with tag. Objects with tag returns a list or an array. We don't want that. We just want the single one. We want get object with tag, and we're going to tell it we want the player tag. Not that. That is the link to the stream. It is case sensitive, so just be careful. And then we're going to also, of that game object, we want the transform. Because our target is a transform, so this is returning a game object, and then we're saying, okay, of that game object, I want the transform, which is just a standard, like, built-in Unity. We can actually clean that up. There we go. Cool. So that's our start method done. So now we're going to move on to our update. Our update method. What we're going to do is we need to move towards our target. So to move to our target, We want to also just throw that check in just in case, because this can mess up. If target is not equal to null, or if target is present, what we want to do is we want to take the quaternion. So how we want to do it? Okay, so what we can do, in fact, let me do it this way, just to show you how things work. So in order to move, we're going to do agent dot set destination equals to our target. Okay, so we're telling the Unity engine's nav mesh, or the navigation part of Unity's engine, that it needs to move to the target, and that's a transform, so we need to pass the position, and a position is the vector 3, so x, y, z location of the target. But now if I go into the game and I run, the AI should, so now you see he's running at me, which is good. And what he's doing is one better as well, is he's actually looking at me, which is an improvement because that's going to allow me to cut out a whole bunch of code. But you can see our main problem here. He is pushing me. You can see on the screen here, he is pushing me. We don't want the enemy to push you, because you can run into a situation where players can actually use that kind of mechanic, quote unquote, there's no such thing as bugs, they're just hidden mechanics, to essentially allow them to break the game. Like, there are some cases where they can push themselves through walls and objects and stuff. So we don't want to do that. What we would like to do is we would like to tell the AI to stop moving towards us if they're within attack range. Attack range is a value we can define in stats, but for now we can do that later. That's not really important. We can have that kind of information set up later. So what we're going to do is we are going to do just take the agent away just to make things easier. We're going to do if the distance. No. We need a distance value first. So what we're going to do is we are just going to have a private float distance to target, and by default that can be undefined. Default that can be undefined. Then what we can do is in the update method, before we after we check for the target, because we can only do this if we have a target, we want to do distance to target. We want to do the distance to the target. And to do that in Unity, it's really simple because vector 3 has a lovely built-in function. It also works in vector 2. But we can do distance to target is equal to vector 3 because we are working on a XYZ plane. Because we don't want to run into a situation where we're standing a floor above the enemy and he's still attacking us, because if we use a vector 2, it only works with X and Z. We want to work with vertical as well. So we can do vector 3.distance, and it takes in two positions. One is the current position we want to check. So in this case, it is this .transform.position, which is basically our zombie. Then we want the target's position. Okay, and then this will return a value of how far away our zombie is to our player. Cool. And then what we can even do is we need the target. Then what we do is if distance to target is less than or equal to, I found 0.6f works really well, and I'll explain that a bit later in a minute. If our distance is less, then we want to stop moving. Else move to the player. And I'm leaving this blank because you'll see why I'm leaving this blank in a minute. Because next we're going to do attacking, and that's going to be fun. So if our zombie is, if our zombie is less than 1.6 meters, I think that's what Unity's unit of measurement is, then it will stop moving towards us. So now if we go and run the game. Oh no, he's still, oh, there we go. Oh yeah, so this is a little bug where if I stop moving, that is going to be the last location. You can see he's pushed me out of the way. So if I, okay, where's a good way of explaining this? So if I stand on this point here, he will push me until he is standing on that point, because that was the point that he last received that location. So what we're going to do is, and this is why we needed this, was if our distance is less than 1.6, we copy this code again, except we're going to do this.transform.position. So basically we say if we're less than 1.6 meters away from our target, our destination is right where we're standing, so we stop moving. So if we go, you see, he stops. Now he stops, but he isn't rotating towards me anymore. And that is because how the move works. And you can see, like, if I stay within the 1.6 meters, he doesn't rotate to look at me. We want him to rotate to look at me. Because it's a lot more aesthetic if the thing attacking you is actually looking at you. It can lead to a bit of player anger if it isn't. So in order to do that, what we're going to do is we are going to take the quaternion. And what a quaternion is, I don't know if I've explained this, but a quaternion is essentially a set of rotations which accounts for something called Gimbal Lock. There's a really good video on YouTube. I'll post it after the stream to go look it up. But essentially, what Gimbal Lock is, if you rotate on, if we have our axes here, so our green, if we have our axes here, actually of this cube here. If we have our axes and we rotate 90 degrees on the X, and then we also rotate 90 degrees on the Y, now we can't, it's a bit hard to visualize, which is why I recommend you go look up the video. But essentially, what Gimbal Lock is, in the easiest way to explain it, is we lock one of our rotation axes, so we can't move the object anymore. So no matter how much we try to rotate, say, the y-axis, because the y-axis is gimbal locked, the y-axis can't rotate. We have to unrotate the other two axes, the x and z axes, in order to start rotating the y. That's a little bit hard to visualize, but I'll find the link to that video. And post it after the stream to help you better explain. But for now, just remember quaternions, take into consideration Gimbal Lock, and get around it. So hello to the person who joined and then immediately left. So we're taking our quaternion. Sorry for the dogs. Just give me 1 second. Okay, I'm back. So we have our quaternion, and then this needs to be our rotation target. Okay, essentially like our movement target, our rotation target is something we want to look at. So in order for us to look at it, so we do quaternion dot look rotation, and our look rotation takes in a vector3 dot. It says vector3 dot forward, but essentially this is, instead of giving it forward, we're going to feed it the direction the same way we calculated direction down here. We are going to feed in the essentially the difference between our position and our target's position. So we want target's position minus this dot transform dot position. Okay. With that'll feed back a quaternion rotation angle, which Unity can then use to rotate our target. So this.transform.rotate, rotation is correct, yes. And then what we're going to do is we are going to feed it our quaternion. Quaternion.rotate towards, and then we're going to do this.transform. So .rotation, so that's our current rotation. So you can see the first value here is from, then to, and then max degrees delta. So how fast we want to rotate. And remember, like, delta is rate of change. So how fast we want to rotate. So we want to rotate from the current rotation that we have to our rotation target. And we want to do it at 5 is a good value. I mean, we can like embed this kind of stuff into stats later. But for now, rotation of 5 is a pretty good one. And then what we're going to do is since we're in our update method, we want to account for variable frame rates. Since we want to account for variable frame rates, we need to use time.delta time just to smooth that out. And now, if we go to our game, our AI will walk towards us. But look, he's still rotating towards us. He's looking at us. And if we keep him going, he's slowly moving towards us. I mean, obviously, like, we can increase that to be a little faster. So we can do 15. Here we go. See, so he's looking towards us. Cool. So now, even though the movement system is no longer updating his rotation, we are updating his rotation for him. And we can, like, so right now they're like kind of stacking on top of each other. So if we really wanted to, like, a little bit of optimization we can do is we can take this out and we can put it inside this other one. So this only kicks, our quaternion rotation only kicks in when we're not moving. So we avoid the agent's movement rotation stacking on top of our coded rotation. Okay, and then what we can do is we can do something. So it'll be really cool if our game breaks, but we would like to know why it broke. So this is something you want to do only in testing. It's not really a good idea to leave these in your game when you publish. So we can say if we have a target, we can then move towards the target. If we don't have a target, remember we've gone through a lot of checks, like in our void start, we have a target. If we don't have a target, we get a new target. But even then, even like after I start, if we still don't have the target, we need to throw an error because something has gone horribly wrong. So Unity uses debug. Oops, that gave away the surprise. So we can do debug.log for just a regular, this is like console.writeline. And so instead what we can do is we can do debug.log error. And when Unity displays error messages with that exclamation mark, let's go to Unity. So this little stop sign, I'm not sure how well you can see it. Suppose I could force an error, but so you've got so normal log messages are just a speech bubble, warning sign, like the rectangular warning signs, that's warning messages, and then you've got the red stop signs, and the red stop signs stop your code from running. So we can say error, no target found. Okay. No target found or set. Cool. And now when we're debugging, if at any point in time we get this error, because it's like our own custom wrote error message, we'll know what's going on. We'll know more accurately where this error is coming from. Okay, so we have our zombie. We have a zombie here. Prefab. Now, he is a prefab. We might have to update the prefab. Now, the only way I unfortunately know about updating the prefab is you can click here. And it says we can override this stuff. So we can revert all to the prefab, or we can click apply all. And this will update our prefab here. You can see now he has the Nav Mesh and he has the Nav Mesh Agent. and the zombie controller. Now you can see the target all of a sudden has vanished, and we can't see, there's nothing we can select, there's no player anymore. And this is why in our code we said if we can't find a target, find the player tag and make that our target. Because when we instantiate this later, remember we want to keep our code separate, so we can't just give it a reference to the player, because then we're starting to intertwine our code and connect our different objects and our code methods and stuff. We want to reduce that as much as possible. So that is why what we've done is if we can't find a target, we just set the player as the target. Now it's a little bit memory intensive, and there's probably other ways you can do it, like if you want to compromise, or when you actually put this in your main project. Remember, because at the end of the day, this is just an asset. These are just assets to use in your projects. When you put it in your main project, then you can assign it when it's going to be something more permanent. But just in trying to keep this as general as possible, this is how we're going to do it. We're going to go a little bit more intensive, but a little bit more versatile. Okay, so now what we can do is we can delete our zombie. Because our zombie is over here, all that data is preserved, so I can drag him back. And look, our zombie's back with everything that we had attached to him. Cool. Nice. Okay. Now, with our zombie in the world, actually, why did I delete him? We still need him. This is the cool thing about prefabs. I can just bring him back. Okay, so we're done with the prefab. We don't need the scene. We're in the zombies. Cool. Now, our zombie needs to attack our player. Because right now, if you remember from last session, our player's health bar is updating because we are causing damage to ourselves, basically. And we don't want to do that. So what we want to do instead is we would rather have the zombie attack us. So in order to do that, we are going to discuss some interesting things. And we're going to get into some scriptable objects as well, just to show you some really cool features Unity has. But for now, we are going to, if I just find where I am in my notes. Cool. Okay. We are going to open our player. Not the UI controller. We want the player controller. In our player controller, we can see if we scroll down to the, not the update, the mouse look. Here. Okay. So we have our get mouse button down, which is making us take damage. We don't want to do that anymore. Go away. Okay. Then what we're going to do is we are going to instead suppose there is no way around it. We're going to have to talk about it now. Cool, because we want the zombie to attack. So now nothing, our player isn't damaging himself. Nothing is damaging the player. So what we're going to do is we are going to talk about scriptable objects. Now the cool thing in Unity is scriptable objects, how they work is they exist essentially outside of your game. Like when we have a normal object, so like if I show you, for example, we have in our global our stats object. Remember, this doesn't derive from mono behavior, so it's not part of Unity's system. In fact, we can actually just get rid of that entirely. So our stats don't derive from anything. And because of that, this data for our stats only exists at runtime. So when I click play, this is only when the stats exist. As soon as I click stop, that data for the stats gets set as overridable in your RAM. Nothing else will change. You can't save it. But if we want to create a whole bunch of different things and different components that need to still exist outside of the game, outside of the game or across levels. So say like you had like a level system for your character. If you go to a new level, which how Unity does that is by changing the scenes. So you see here, and we have sample scene 1. This is going to be think about as level 1. If you go to a different level, all of a sudden, all the data on scene 1 that is stored, how we are storing it, will disappear because it's not being saved anymore. It's being rendered and held on a different scene. Now, what a scriptable object is, a scriptable object exists outside of this. And to do it, to create one, we create it the exact same way as a regular script, but this is a global, so because everybody's going to be able to use it. So we're going to create a new C# script, and we're going to call this the combat channel. Can I type? Event. No, scriptable object. Okay, we're going to open it. And now instead of it deriving from on a behavior, we are going to derive it from scriptable objects. Okay, and now it'll be really nice, and if we can create that. So remember before when we were working with serialized fields, okay? And what this does is if we have like something here, it will appear in our editor, okay? It'll allow us to go into our editor and see the values there, even though we haven't made it public. So we can do something similar to it, but we can do create asset menu. Create asset menu? Where did it go? Nope, not there. Ah, there it is. No problem. Found it. Okay. So what we're going to do is we're going to do create asset menu. And this will create a new thing in our asset menu, like a new instantiatable. So we can do menu name, we can give it a name, and we can name the scriptable objects. And then we can add a / to make a new folder, and then we can do combat. Okay, and now if I save this, let me go back into Unity. What I can now do is right-click, create scriptable objects. Remember before folder was at the top, now it's scriptable object. And then channel is there now. So now this is the cool thing. We've essentially created our own version of a create. So we can, like shader, render shader, 2D, C# script, we've created our own version of this. And the cool thing about this is this exists outside of everything. So we're going to create a new folder. We're going to call this channels, or yeah, channels. Okay, just to keep everything organized, and I'll explain why I'm calling it a channel in a minute. And we're going to create a new scriptable object. Whoops, if I click on it. And we're going to call this channel, combat channel scriptable object. Okay, now we've created our own one. So the cool thing is, we can see up here, our script attached is the combat script. Combat channel scriptable object here. Oh, whoops, not just combat channel is fine. So you can see in here in our inspector, the script attached to this object is this combat channel. Now the cool thing is because this exists outside of our game, everything can reference this, even if that item doesn't belong to the game. So you know how I have like this prefab of our zombie here? If I go to prefabs, our zombie, and then I lock this window. So you can see how target doesn't exist, but this zombie's target does exist. If I take the scriptable object, I can now reference this scriptable object, even though the zombie is a prefab, even though the zombie doesn't exist in our game. Which is the cool thing about it. So we just unlock that. Okay, let's go into our scriptable object. Now, how this is gonna work is in our last session that we did for the player UI controller. Our player UI controller was using was just listening. This player stat.on player taken damage was just listening for this call, and our stat screen was broadcasting the call that our UI was listening for, and our UI would then execute the player on damage taken method when stats say, hey, the player has taken damage. Okay, like this is our event system, our actions and event systems. The channels that we're going to be doing for our scriptable objects are very, very similar, but with one key difference. A channel is what everything talks to, and the channel then talks to everybody else. Now, what I mean that instead of this take damage sending a message out into the unknown, instead what it's going to do is it's going to tell channel, hey, can you broadcast this message for me? And then channel's going to take it and broadcast it. Now, why are we doing it that way? Because this invoke here is telling, we don't know who it's telling, essentially. We're not sure who it's communicating to. I mean, we wrote it, and we know in this instance who it's talking to. But in more complicated projects, we might not always know what is talking to what. And the thing with the invoke systems is it won't tell you something is wrong or something is missing in an error message. You have to figure that out. So instead, what we're going to be using these channels for is we're going to be using it to reference and to communicate in one centralized location, so that if we want to update something, we know exactly where we need to update, we need to go, and we need to change. And if we change something here, we know it's going to affect everything. We know it will affect, we know it'll affect everything. We know we're not very likely to miss something, to forget something in that update. So it's just a way of centralizing things. The first thing we're going to be doing is we're going to be creating an action for when the zombie attacks the player. Okay, so this case we're going to be doing public because we need everybody to reference this. So this is actually like a genuine public. Oh, I forgot. We need to be using Unity Engine dot. No, not Unity Engine. We need to be using system because we're using the C# events, C# actions and events. Okay, action. Now what we're going to do is we're going to say, okay, I need a data type of a float. Okay, and then zombie attacked event raised. Okay, so we raised the attack event. Okay, I don't need instant replay. The zombie has basically has raised his hand and said, I've attacked somebody. Now what channel is doing is channel is taking that information and is then going to say, hey, the zombie attacked somebody. Okay, and it's completely disconnected from everything. The only connection is from zombie to this channel system. That is the only connection made. And to remove it, very easy. It's very easy to remove it. It's very easy to change it. And it makes your code it turns your code into puzzle pieces, essentially. You can just, more like Lego bricks. You can swap and match and change however you want. Okay? So, and the cool thing is we don't need constructors, we don't need anything. So instead, what we're going to do is we're going to do public. We need a float, but it's okay because this method is different. So we're going to say, okay, what method is going to invoke this action response? Okay, what method are we going to call for the combat channel scriptable object? Oh damn, I wrote OS. Anyway, for the object channel, that would break things. So for now, we'll just go with OS. I'll fix it later. For the combat channel. Actually, let me quickly fix it because that might cause problems. Global. We're going to rename this to SO. Copy that channel here. You updated correctly. Yep, that's good. Reopen you. Cool. Okay, so now everything's up. So for our... Oh, hang on, wait. You need to be swapped around. There we go. This is very important that the class name here matches the name of the script in Unity, otherwise bad things happen. Okay, so So this method now that we're making is something that somebody broadcasting to the channel, like a similar way that that's a good way of describing it. The similar way I'm talking to you guys now. I am broadcasting to YouTube. YouTube is then broadcasting to all of you. I don't have to individually broadcast to everybody watching this. Because I don't care if somebody's watching, if 1,000 people are watching, if nobody's watching, I am just broadcasting to YouTube. YouTube's doing the rest. And if I disappear, YouTube doesn't crash. That's the important thing. If YouTube crashes, then I have problems, but at that point you have bigger issues. So the method that's going to be called will be the we're doing zombie attack player, so we're going to be doing zombie attacked player. This is a method call, not an event. And now, in order to match our action typing, we are going to need to pass in a float amount of damage that the zombie is doing to the player. And now we can do zombie attacked event raised. So this is very similar to what we did in the last one. So we can do the question mark to make sure it's not null, because if it's null, it can cause a problem. .invoke. And then what we're also going to do is we're also going to pass the amount. And this is what, so now we've said, hey, the zombies attacked the player and he's done this. And this value is going to accompany that message. So the zombie has attacked player 10. And other parts of our code will be listening for the zombie attack the player, and then also it can take in this information. So with the zombie attacking the player, all good. We go back over to our player code, our player controller, not movement, enable. Okay, so now what we do is we need to make our player listen for that information to come in. So we're going to do on enabled and on disabled, not destroyed, on disabled. Okay, so now this is just to help. The on disabled part is for cleaning up some memory. So we need a reference to our combat controller. So what we're going to do is we are going to do a private. Actually, we're going to need a serialized field, if I can type. Serialized field, private. Combat channel OS. Combat channel. So this is the combat channel. So I know by subscribing my player to this combat channel, everything that happens that's combat related, my player will also be listening for. And if I wanted to stop listening to it, I just unsubscribe from it. And that is the power of it. So we're doing zombie attack player. No, not the event raised. Oh no, yes, event raised. So this is now the player listening for that event being raised. So we're going to plus equals, and then we want to do the player take damage. We need the player to take damage now. So we're not going to put that in update. We're going to create a new one. We can make this private. Void player take damage. Oh, not taken. Player take damage, and then we want the float amount. Okay, the player take damage float amount, and then all we do in this is player stat dot take damage, and we're going to pass amount. Now that method might seem a little bit useless, but all it's really doing is it's just passing information along. Okay, I'm not sure if this would work. Maybe somebody else can research that. I'm not sure if that will work, but that's basically a temporary method. But we're going to pass in player take damage, and then, oh yeah, no, it's just a reference to a method. So now whenever the combat channel says, hey, the zombie is attacked, the zombie is attacked, the event, the zombie is attacked, run this method. So it's going to call this method. It's going to say to the player stats, hey, I've taken damage. Player stats is going to go here. Player stats now no longer needs to invoke. Actually, for now, let's leave the invoke, because the UI is still going to be listening for that invoke. But we will make that change very soon, and that's when you'll see the power of this. Let me just check how long I've been going Or 58 minutes. Okay, not too bad. Plus also I think I was like delayed in the beginning, but anyway, it's okay. Yep, so then so we have our stats. Our stats, we'll leave the invoke just for now so we can see we can make sure that it's testing and working. Then what we're going to do is we are going to, nope, everything's good there, all good there. Oh yeah, on the disabled, it's very important that when you add something to the listener, you also remove it if at any point in time the player controller becomes inactive or deleted or destroyed. So also like another good practice is on destroyed. Also remove it. Because the problem is you destroy it, you remove references, and that's how you get memory leaks. But we know the player controller is not going to be destroyed at the moment, so that's just some code simplification. So the zombie controller, let's just follow things, how it's going to go. So we need the zombie to now actually attack the player. So the zombie controller, we're going to need reference to the combat system. So once again, serialized field. Then what we're going to do is private combat system scriptable object combat system or combat channel. Okay, I keep saying system, sorry, I mean combat channel. Okay, so we're going to do the combat channel scriptable object. Then what we're going to need to do is, so here's the cool thing as well. So we have our reference to our combat channel. If I go back into Unity, let it compile. So now if I go to the prefab, here, we can see that the combat channel, I can now add a scriptable object, even though it's a prefab, even though it doesn't exist in our game. And because of that, as a proxy, I now have the combat channel added here. So now all my prefabs have been updated with my combat channel, without me needing to go and hunt for them, look for them. That's one of the nice, powerful things about prefabs. Then what we're going to do is we get the direction, move there. Okay, now we're focusing on the attack. So what we can do is we are going to take our code out and we are going to change this to move to target just to keep things nice and clean in the update. Remember, we don't want to like overcomplicate update too much. Void move to target. Okay. And now what we can do is we can just hide that just to keep things a bit clean. So the last thing we're going to do is move to the target. Then what we're going to do is we are going to actually, now we need the distance vector taken out and put here. And then as a proxy, in order for this to work, in order for this else statement to work, if ending here. Okay, yeah, as a proxy, we need this to be taken out, but the cool thing is if it passes, okay, sorry, I'm rambling. Allow me to explain. We need the distance out because we want to prevent code duplication. So I'm removing distance, the target, the check to see if the target exists. I'm removing it out of the move to target, and I'm going to wrap it just around the distance to target portion. Here. Distance to target. Because, and we can get rid of some of these just to shrink. So basically, this will throw an error message which will stop the game from running. So we don't have to worry about it continuing the code with a null value, because the only way it's getting here is if we do actually have a target. Because else it's going to throw the error, it's going to stop the game from running. This is also why you don't want to leave log errors in, because a log error will halt the game. You'd rather do warning messages or have like your own error message system. And the cool thing is you can also use scriptable objects for those error messages. Cool. And then by default, we can say the distance is 0. By the distance is 0, we can say that. Yep, all good, all good, all good. We can, since we're recalculating that as well, we can add just an extra layer of security and just say the distance is 0 to begin with. or the distance is 999 to begin with, just so it's not, the zombie isn't randomly attacking our player when he's miles away. Then it updates the distance value. That's just a layer of security. Okay, then what we're going to do is we're going to move. After the move, we need to do the attack now, which is really good. So what we're going to do is, if the distance to target is, actually we're going to change that to 1.5. So if, once again, distance to target is less than or equal to 1.6f, so just a little bit out of the stopping range, and that's because if the zombie gets close enough to the player, we don't want him to stop first, then attack. We'd rather have him attack whilst he's stopping, because it can help cover up some animation differences and also make the zombies feel a bit more active and dynamic. It's not really, it turns more into a chess game if the zombie runs up to you, stops for a second, and then attacks. So we'd rather have him attack whilst he can still move. What we're also going to do is we are going to need a reference to the zombie stats, actually. So let me just clean this if statement up so it won't bug. We need the zombie stats, private stats. Luckily enough, this shouldn't be needed by anything else, not stack, stats. Private stats. There we go. Stats. Okay, and then on void start, we get all this, and then we want stats equals new stats, not string, stats. This is the stats for the zombie. We're going to set his health to begin with at 100. His attacks, remember, because we all have our default values, so we can just leave that blank. Then what we're going to do is below our stats, try to keep all the floats in one place, private. We need to work on our attack speed, because we don't want the enemy to attack however fast our frame rate is running, because that might kill us a little bit quicker than anticipated. So what we're going to do is time to next attack equals 0 to begin with. And then this is how long, as you can probably tell, this is how long or what time the next attack. So maybe time next for next attack. Time for next attack. Okay, so at what point in time the next attack can happen? So we go back down here to our if statement here. So we can say and if time.time, so if the current time is greater than time for next attack, then that's good. Then the enemy can make an attack, which is really good. But then the first thing we want to do is time for next attack equals time.time time plus our stats dot attack speed. And what this will do is this will say, okay, so the next time we can attack is the current time plus 1 second at the moment. So our attack speed for our enemy is 1 attack per second. 1 attack per second. And we just want to keep updating that. So we don't want the enemy to be able to attack too fast. And we can tweak this with the settings. Different zombies can have different attack speeds. And we won't have to change any of this code. All we change is our stats. So instead of like stats, we can say movement of 10 and our attack speed of 2. So now our zombie attacks once every 2 seconds. And we can change that. However, we can even make a dedicated manager for that kind of stuff. And we won't have any problems there. Cool. Now, next what we're going to be doing is we're just going to be continuing with the attack speed. So we've got the attack. And now to use the combat channel we set up finally. So combat channel dot zombie attack player. Remember, we're not raising the event, we are calling the method. And how much damage is this zombie attack going to do? We need attack damage. Okay. So remember, we're not calling this. This is the action is what we're listening for. This is what we're calling. So, oh, actually, hang on. That's zombie. Let me just update that. Zombie. The method is what we are calling. It's what we're telling the channel to say. And then the action is what we're telling the listeners of the channel to listen out for. Yeah, so just, it's a little bit difficult. Don't get those confused. If something's going wrong, most likely that is probably like the first place to look. Okay, because the other way we could do this, if we wanted to keep things interchanged, if we wanted to like lock, like if we wanted to start like making our code spaghetti, our code files spaghetti together, so like intertwined and stuff, is we can just simply do, the easiest way to do it, if you're trying to keep things simple, is we can do the target, because we already have the target, dot get component, and then we can say get component, and then we're looking for the player controller. Okay, and of this player controller, we are going to get the player stats, and then we're going to say dot take damage, and then we're going to feed in our stats dot amount dot attack damage. Okay, the only problem is that now if my target disappears, it's going to break. If the target I have doesn't have a player controller, it's going to break. If the attack damage script disappears at some point, the take damage method disappears at some point in the future, it's going to break. Whereas if we do it this way, it doesn't care what happens. This code doesn't care what happens. It will just execute and run and do its thing. And that is the cool thing about it, is it'll just, regardless of what happens outside of this script, it will just do its thing and run. And that's the important thing. At the end of the day, the game runs. Like with everything, we can pay for microtransactions to fix it later. Yep. Okay, and then we're going to move to target. So we can, if we wanted to, we can wrap this up in its own little method. It's going to be a little bit trickier now because we've started introducing some complexity with a target distance. So if anything, this is most likely the only thing we can remove. So for now, we'll just leave it there. Not good thing to do, but for now, we'll just leave it there. That is our zombie now attacking the player. So let's double check the script. See if it works. We have a null reference error. That's fine, probably because our zombie doesn't have a reference. See, our zombie doesn't have a reference to our player. We want a reference to our player there, which is interesting because that means this didn't fire. That's very interesting. Okay. I have a reference to the player. Still null reference error. Okay, it's not occurring there. It's occurring line 31. Zombie attack action raised, null reference error, player take damage amount, that's fine. Combat channel is okay. What happened? Oop. What did I do? What did I do? Operator is not sent to an instance of object.unenabled, on disabled. Yeah, it's definitely that. Player take damage. Okay, we're gonna throw in a little. Oh no, it's happening on runtime, which means. Oh, don't tell me I'm running into this problem again. Nope. Am I checking for... Yeah, I'm checking for null values, which is okay. Does the zombie attack... It's very interesting. What happened? Oh no. Zombie actually started moving towards me. Which is good. The errors are happening on the player. Oh, yes. Okay. The player is now trying to say, hey, where's the combat channel? So we need to also reference the combat channel in the player. There we go. Now the zombie attacked me really quickly and just ate all my health. which probably means that the zombie is not taking into consideration the attack time. If the time is greater than time for next attack, so he does the first attack, then he sets the attack to the next attack speed. Oh, yes, I came across this bug. We had a bug in the stat screen. Last time when I created it. We forgot to actually assign our attack speed, so it's always going to just be time, the current time plus 0. So we need attack speed equals attack speed, not damage, attack speed. Attack speed. Now it should work. Just small bugs as you go along. So now if he walks to me, you can see he hits me again, hits me again. Now all this is happening, all of this data is happening completely independent from one another. The only dependency in this project is now this combat channel. Everything else around it can be removed with no problem. With no like negative effect on the game, nothing like that. As long as combat channel exists, the game will run perfectly fine. The systems will work, the system will communicate to each other, everything is all good. So let's focus on, now that we have the zombie attacking us, let's get the ability to fight back, shall we? We need to punish the zombie for hitting us. So what we're going to do is we're going to go back to our channel scriptable object here. We're going to add a few new things. So we're going to do so we have one for the zombie attacking. So now we need one for the player. This one is also going to be, we can make it a float, but since the player's only going to have one kind of damage, is it really necessary? We can make it a float, it's fine. Player attack event raised. So the reason why I'm using event raised is trying to just keep it a bit more, make the code a bit more informative. Because I'm essentially, this action is being raised, by raised I mean called, when this is triggered. It's like, think of it like a flag being lifted. The player attack flag has been lifted when the event is raised. Not raised. Next, we need to make the method that our code is going to tell the channel what our code is going to broadcast to the channel. So what we're going to do is player, it needs to be void player attacked zombie. Player attacked zombie. It needs to take in a float for the amount. We also need to know what zombie the player attacked. So zombie controller. Because the only thing that because at the moment, hang on, this also needs to be amount, the amount of damage we want to do. Because there's no connection, the player shooting a zombie, from the code's point of view, the code doesn't know what zombie the player just shot. Other parts of the code, the player knows which zombie you shot, you know which zombie you shot, but the other parts of the code doesn't. So we need to pass this information along through the channel. So we make like, it's not a permanent link or anything like that. It's just an additional requirement where one of the requirements is when the player attacks, it has to pass a zombie controller. And we're just doing that purely because if something breaks, it'll break here, not somewhere else deeper in the code. Okay, so now what we're going to do is zombie controller dot. Oh, hang on, we don't have that function yet. We don't have a zombie take damage function. So we're going to just need to create a quick. This needs to be a public. Yes, public. Public? No, this needs to be a private. No, public. Hang on. My brain's not working. Yes, public, because it needs to be, it's being No, what am I doing? It doesn't. It doesn't. For the sole reason of the whole reason why we're doing this. Private zombie, private void zombie take damage. Zombie taken damage. And what we're going to do is we're going to pass the amount. Oops. Oh no, yes, this has to be public, and I'll explain why. So this has to be public because in this instance, and essentially I'm doing this to save on processing power, to make the code just run a little bit more efficiently. So now I'm doing the opposite of before, where I'm sacrificing modularity for performance, because this performance hits a little harder. The reason why we're making this public is we don't know what zombie has been attacked. I mean, we know here what zombie is attacked, but if I just invoke it and I say, hey, a zombie's been attacked, we don't know, there's no way of the zombie, like all the zombies listening to this channel, to know, hey, that's me. We can do other things, like we can broadcast an ID for the zombie, or we can broadcast some kind of information for the zombie that each zombie can compare. But the problem is all the zombies suddenly comparing a script to see if their script matches is quite heavy in performance. So instead, we're just going to use like a lot simpler of an approach. We're just going to invoke that method, and in order for it to invoke, we need that to be public. Yeah, we're just going to call that method in order to call it to be public. So we're just going to do zombie taken damage. We're going to pass the amount. Okay, so we say for the zombie that we've been told has taken damage, that zombie, hey, take damage. There are ways of doing it. There are certainly ways of passing specific data so all the zombies listening can know. It's just not going to be easy to explain, and it's going to be a little more complicated to implement. And then what we're going to do is we want to raise this event, player attack event raised, question mark, because remember we want to check for null values, and then invoke. And now this will allow us to oops, did I misspell it? Dot invoke. What happened? Oh, right. So we need to pass it a float. So we want to pass it the amount. There we go. So the reason for the error there is this invoke was expecting a float value because this is what this action takes. So we also needed to pass an amount into it. And then this can be used for like our UI, any form of particle system we want to implement now. So it's saying, hey, the player's attacked. Spray some blood somewhere, or update the UI, or like our ammo counter or something like that. So now this is the player attacking, so we go back to the player controller. No, not the player controller. Actually, we need to now go and modify the gun code. Player, gun controller. Now in the gun controller, small updates, just some small changes. So we're going to say get button fire. We are going to then duplicate the script we used for the zombie attack speed. So time.time is greater than player next attack time. We need to declare this. Private float player next attack time, which is going to equal 0 by default. Then what we're going to do is when we come in here, we're going to do player next attack time equals time.time. Oh, we need access to the stats. We need access to the player stats. So that's okay. That's like a conundrum now, because we can intertwine. And by that I mean we can tell the gun controller the stats of the player, but player controller doesn't have a reference to gun controller, and gun controller doesn't have a reference to player. And because of that, the gun controller won't know what the attack speed of the player is. But here's the cool thing. Player controller and gun controller are on the same game object, so we can just simply reach out and grab it. So, and grab our player's stats. So we're going to specifically grab our attack speed. So private float attack speed is going to attack speed is going to equal 0 for now. Okay, and then in start, what we're going to do is, oh, hang on, it helps if you have an equal sign. Okay, then what we're going to do is we are going to do the attack speed is equal to get component. We are going to specifically look for the character controller because this is what's holding our stats, and this is player stats. Come on. Is player stats not public? Our player stats should be a public, yeah, public get protected set so that it can't be overridden. Oh, character control. No, player controller. There we go. Player stats. And then we want the specific stat we want, so attack speed. Cool. Now we have a reference to our attack speed. We can add the attack speed here. We can add the attack speed. So now, same code as before with zombies attacks. Identical code for player attacks. Really easy, really easy. Cool. So we have the player next attack time. Instead of saying we hit something, because, I mean, we can keep it, but that's not necessary at this point in time. Now what we want to do is we need to check what we've hit. So if we go back into our game, and I'm going to sneeze. Okay. If we go back into our game, we can see how our player has the player tag. And then our zombie doesn't have a tag. So we can click add tag, and you can see I've already added the tag, but what you can do is you can click this plus, and you can type in the name of the tag you want. So I have it as set as zombie. And you can remove these tags, you can add these tags. You can't change them, like that's the only problem, is you can't edit them. So once they've been added, you can't change them, you have to remove them and add a new one again. And these tags can be called by their array number, so like if I called tag at array 0, that would be zombie. That's probably a better way of doing it, just to make sure, but the problem is if things switch around, it could cause problems, so in that case it's better to search for the name itself. It is case sensitive, so just be careful. So now we can assign the zombie tag, and then we can update the prefab. So now our prefab over here, like before, now also has the zombie tag. Oh, also remember, whenever you make changes to the script, you don't have to update it unless you have assigned things to it. Okay, so we're just going to go back into our code now. Now we need to check that what we hit is a zombie, because we don't want to be doing damage to a zombie if we're shooting a wall, or if we're shooting another player, maybe if we make this multiplayer at some point. So what we need to do is if, oh, that's really, I'm not used to the big sizes. If they hit, remember, because all in the physics.raycast, all of the information that we're getting from the physics engines, that laser pointer it shot out, is being stored, is being output to our hit method, our hit variable over here, our raycast hit. And then this has access to the transform, and then after transform has access to the tag. And then we can say the tag equal to zombie. Okay, remember it is case sensitive, so if I did zombie, it would not work. It has to be uppercase. What is this? Oh, I can't do that to a float, to an if statement. I don't know why I said float. Okay, and then we want the combat channel scriptable object dot player. Oh no, right, we need to create a reference to the combat. So we're plugging this into the combat channel. We want this private combat channel. Private combat channel. Actually, this needs to be public, or I suppose it needs to be a serialized field. So we can assign it. So we want the combat channel dot player attacked zombie, and then inside it, remember the two things we need to pass it. We need to pass it the amount. So the gun also needs access to the. So here the gun is getting access to the attack speed. So I think instead of doing this, what we can do is we can just grab a copy to the full player stats. Stats equals stats. Then instead of attack speed, we want just the player stats. There we go. Then we want stats dot attack speed. And then, so now what we have to do is, remember, we have to pass it because our combat channel is expecting, our combat channel method is expecting the float amount of damage and the zombie we've shot. So we want to do stats dot attack damage. Attack damage, and then we need hit.transform.getComponent zombie controller. And now what this is doing is this is passing the zombie controller component over to our combat channel. So our combat channel is requesting a zombie controller game component, and we're now passing it. So that information is being sent over correctly. I think that is it. The zombie, what we can do to test this out actually is if we go to the zombie controller, zombie.take damage. Oh, we never updated this. Right. So zombie.take damage, what we can do is we can do a debug.log. Remember, log does not end your game. This is like console.writeLine or system.out.print. So we can do here zombie taken damage. Okay, zombie taken damage. And then we can do some calculations. So we can do the zombie.take damage, because remember our stat is universal. Our stats are universal, so we can just call that function and we can pass in the amount. And then if the stats.health, remember health is the current health of the zombie, not the total health, is equal to 0, we can then say combat channel. Oh, we don't have that written either. We don't have that written yet, so we can just leave, we'll just leave that blank. And then what we can do is we can just copy this here, put this here, zombie has died. Zombie has did. Sure, why not? Zombie has died. Cool. We go back to our code. Launch the game. Oh, wait, no. It'll give me an error. Oh, it should give me an error. I don't think it will. It probably should. I feel like it should. Because our gun does not have a reference to our scriptable object. So now we go into game. We click, we shoot, zombie has taken damage. You see, this has been done now without a direct connection to zombie. Same as like when the zombie damages me, that's done without a direct connection to me. So this is all independent now. So zombie takes damage, zombie takes damage. Remember, I'm doing 10 damage per shot. So I just keep clicking, zombie's taking damage, and he should die pretty soon. Hopefully. There, zombie has died. But he's still following me around, he's still chasing me. This is a very persistent guy. So we don't want that. We want the zombie to die. So instead of saying zombie has taken damage and zombie has died, because we know that system works now. Oh, and if you, I probably should have pointed out, it's down here in the debug window. And then what you can do is you can also collapse. So you can see our zombie has taken damage message was sent 10 times, and the zombie has died was sent once. Perfect. Working exactly as intended until I said that right now. So, if the zombie's health is less than or equal to 0, I'm just using that to make extra sure, because even though our stats take damage is blocking it at 0, I'm still just adding this in as like just a safety sanity check. We can do the combat channel. We need to tell the combat channel that the zombie has died. So other parts of the code can remove it, and then we'll get into that. We're going to probably run a little bit over with the session, but it's fine. Because we still have to do, all we have left to do is the wave spawning, and then we're done. So let's get right into it. So we need the zombie has died. Oh no, the zombie has died. So public should be pretty easy for you by now. We're going to make a new action. Action. What zombie has died? We need the transform of the zombie that has died. Maybe has died, zombie died, event raised. There we go, that sounds a bit better. Zombie has died, event raised. Okay, cool. Now we need a new public void, zombie died. And then we need to transform, and we need to know what zombie has died. Okay, and then when we receive that zombie has died, we can do zombie died event raised, question mark, because we want to check for null. You always want to check for null, because if it is trying to call something that isn't there, if nothing is listening, it won't work. And that's just like a little optimization that Unity has built in. So invoke, and we need to pass in zombie. Okay. So now in the zombie controller, what we're going to do is we're going to raise the event. We're going to say, hey, we've died. Combat channel dot zombie died. We're going to call that method so the event can get raised, and we're going to pass in this dot transform, and that'll pass in all the necessary information. Cool, and that's the zombie side done. So now if the zombie does die, it'll inform the rest of the code. But we don't want the zombie here to remove itself from the game, because there's a little bit of optimization we can do later down the line. I'm not sure if I do run another class, I might show you that way of optimizing, because it is a very clever very clever system. I just need to find the guy who I saw it from, so I can also give him credit, because it is amazing. Yeah, okay, so the zombie controller, zombies, then telling the combat channel scriptable object that we have died, which is all fine and dandy. Yeah, so what is going to be responsible for removing the zombies? What is going to be responsible for removing the zombies? So we can get rid of zombie. Because we are going to need something in our world to keep track of all the zombies on our level. So we're going to create a new object called zombie. Zombies. Make sure this transform is reset to the center so we don't have any spawning problems. And then on the zombie, this zombies, this is just like a folder system that we're going to be using just to keep things nice and clean. We're going to go over to zombies, and we're going to create a new C# script and call it wave controller. Okay, and the wave controller will be responsible. The wave controller will be responsible for spawning our zombies in waves for our rounds. So we can actually now take all of our components and put them together into a game that we can play. Finally, after 4 weeks, we can finally play a game. I am so fast at this. Okay, so what we're going to need to do, we are going to need some areas for our zombies to spawn in. So we're going to do a public, because we might need other things to access this later. And we're going to use everybody's new favorite, as you guys probably know by now, list You guys are probably well aware doing 4th year. List, and then we want transform. List data type to be transform, and we're going to call this spawn points. Okay, and these will be the areas where our zombies can spawn. And then we're going to need a reference to the prefab now. So we want public game object. We can make this a serialized private, but it's fine. Prefab, a zombie prefab. Now with this, we can also replace with a list of game objects if we have different types. If we have different types of zombies. Okay, next we want to keep our other data nice and separate, so we're going to do a public int first wave zombie count, and then the starting wave we can go with like 15 zombies. The reason why we're using int is you can't have like a floating variable, a floating point of a zombie. You can, but I think that's after the player would have shot him a few times. Next, we want to make the difficulty of the wave increase, so we want float wave difficulty mult. It's just the multiply, so we're going to go with 1.2, so like a 20% difficulty increase every wave, which is basically relates to the wave spawning 20% more zombies. Then finally a public float wave number. I hope everything's okay with the audio. Let me just put my headphones back on. It ran out of battery at the beginning, and I see people like jump in and then immediately leave. I just want to make sure like my audio's not messed up. Otherwise, I'm going to have to redo this, and I'm going to get mad. Test, test, test. Okay. Wave number. Why can I not hear myself? That's a little concerning. Technical problems, 1 sec. Okay. No, that sounds pretty good. That sounds like it's working. Good. Okay. Everything's good. Let's get back to it. So the wave number, we're going to start that out as 1. Wave number can probably be an integer as well, because you're not going to have like wave 1.5 unless maybe if you wanted to do something like the dogs from Call of Duty. The dog waves, but I think that was just every 5 waves. Okay, wave number, that's fine. Wave number, yep, we can set that to that. All good. Now, let us focus on keeping track and spawning the zombies. So what we can do is we can do a private. So now, now what we're going to do is we're going to keep track of all the zombies that we have spawned into the world. So because we're going to need to know who they are in order to remove them later. Because the zombies aren't deleting themselves. The wave controller will be responsible for removing the zombies. So we're going to do a list of game objects, and this is going to be called zombies in current wave. Okay, just so we know about it. Then we're going to do a serialize private again. We're going to need a reference to the combat channels, the combat channel scriptable object, because we're going to need to receive some information. Combat channel. Okay, cool. And then on enabled, we want to subscribe to the combat channel that we need to listen to. So zombie died, event raise, plus equals. Oh, we don't have the method yet. Okay, so what we're going to need to do is we're going to do private void zombie died, and then this one's going to be a transform. Remember, it's not going to be a game object because the information that we are receiving from our combat event, combat channel, is a transform, not a game object. It's only a game object when it comes to the wave controller. So we're going to pass in zombie died. Then we're going to need to copy this entire function, and then this one is on disabled. Oh, come on, really? You're not going to make my life easy? Probably could have typed it out by now, but now it's now it's personal. And we're just going to minus it from that. I have a sneaking suspicion in the player controller. I did on enabled. No, okay, perfect. So the wave controller like this. And then there are other ways you can shrink this down. Like if you really wanted to, you can just put the whole thing on one line like this. Because honestly, not much in our code is going to be stored in the on enabled or on disabled. So that's just some way you can do, like shrinking your code down a little bit. Okay, the private void zombie has died. So what we can do is we need to remove the zombie from our list. So right now there's nothing in our list, but just pretend there is. Just to keep everything all in one go. So we want zombies in current wave dot remove, and then what we're going to do is we're going to remove the current zombie dot game object. Remember, because like a transform has access to a game object and a game object has access to a transform. It's kind of like both, it goes both ways. So we're just going to say, hey, from the current list, remove the current zombie game object that we have stored, and that game object data is coming from the transform of that zombie. Then once we have removed it, we're going to do something, because right now we're lazy and we're running out of time. We're just going to destroy the zombie. Now, ideally, this actually now we need to actually add this change. I don't think we have it. Yeah, okay, so you're not subscribed to anything, so that's fine. Ideally, like I said, if I do run another session, I'll show you. What you want to do is you want to like create a whole bunch of zombies, and instead of destroying them, make them disable them, move them to a location where the player can't get to them, and then when you need to spawn new zombies, move them back to one of the spawn points and re-enable them. It's way less memory intensive, because with destroying you're getting the garbage collector involved, and you're getting other things, and you're having to recreate variables and information from scratch every single time. And this is bad, but I'm only doing it because we're running out of time. That's the zombie died portion finished. Then what we're going to need to do is, above that, we want to do the update. We need to update the... No, we need actually we start. We need some zombies in our world. Which would actually be very useful. So zombies in current wave equals new list of game objects, and now we need to create the zombies. Now we're gonna make a new method for the spawning of the zombie wave, because both the update and the start method are going to need it, and it's just going to save us a bit of code duplication. So private void spawn wave, and then we can do int amount, the amount of zombies we want to spawn for the wave. Then we do for, and then the nice thing about Visual Studio is you can do for, tab twice, which automatically generates a for loop, tab again to get to the middle, and then we just do amount, tab again, hit enter, and now we're inside the for loop. I love Visual Studio, like autocomplete so much. So what we need is we need to get some spawn points. Yes, we have spawn points. So we need a random number because we need to pick a random spawn point. So int random equals math f dot random. Oh no. No. Random dot range. Math f is the different one. Random dot range between 0 and spawn points minus dot count minus 1. So no matter how many spawn points we have, I suppose we need to check. We'll probably need to check if spawn points is at least. Do I want to do that? Okay, what we can actually do is we can make this a bit fun. So what we can do is we can do a question mark. Spawn point dot count greater than 0 question mark. Okay, now this is basically an inline if statement if you want to think about it like this. So we're saying if the spawn point dot count is greater than 0, then what we want to do is we want to do spawn points dot count minus 1. Else, if it's not greater than 0, just pick between 0 and 0. Okay, so it'll just always pick the first spawn point. I mean, I suppose we could. This could also mean that we don't have any spawn points. So if not, what we can actually do is we can just set it to -1, and then we can have like another. We can have like an if statement that checks if random is greater than or equal to 0, proceed, and if not, we can just spawn the zombie in the middle of the map. Yeah, so we're just doing that. I mean, I suppose it's okay. Doesn't matter. Then what we're going to do is we are going to do game object. Oh no, it has to be capital because there's also a lowercase game object which can mess with you. Game object G, or we can call this zombie game object equals instantiate, because we need to create our prefab that we made all the way back at the beginning of this. Our zombie prefab, which we have a reference to. Yes, we do. We have our zombie prefab. And now it's going to take in a transform. Ignore the parent one. It's not that one. Vector 3 position, quaternion.rotation is what we're going to be doing. So we want spawn points at index random. Dot position. And then we want quaternion.identity. And quaternion.identity just means whichever direction you were saved as. So whatever direction you have stored internally as your identity, just use that one. It's not like we can give it a specific rotation if we want the zombies to face a specific way, but right now it's just however the prefab is saved. Then we want to do zombies in current wave dot add to the list, and then we want zombie game object. Cool. And when the zombie dies, we are removing the zombie game object. And then at the beginning of the game, we just want to spawn 5 zombies. Now, if we go in, fingers crossed, if everything works, they should be somewhere. Where are they? Nope. Because I haven't created any spawn points. See, our code saved us already. So in our world, we can make it selectable again. In our world, we can right-click, empty, and we can go spawn points. And then this one, make sure it's at 0. And then what we're going to do is we're going to create empty spawn. We're going to say spawn point 1. Now, this is something interesting you can do in Unity, because how Unity does duplication, if we do bracket 1, bracket, if I duplicate this, oh, hang on, wait, bracket needs a space. We're basically forcing the editor to name things for us, which we like. So now if I duplicate, see, now it's 2. If I duplicate again, 3, 4, 5. So because we essentially made it think it already had a spawn point 1, we can drag one over there, one over there, one over there. I mean, like, you kind of want these out of the view of the player, so you want them at like the edges of the map. So we've got 3 spawn points. And So for each zombie we spawn in, we want to give it a random.range. We want to give it a random spawn point, spawn in it at the random spawn point, add it to the current zombies in the world. If the zombie does die, remove it from the current zombies in the world. So let's go with that. So now, oh, yep, no. Almost forgot. So our zombies, we need to add, oh, shoot, okay, we have to add the controller. I can't believe I haven't done that. So our channels, combat channels, we add as combat channels. Our zombie prefab, we want to go to assets, and there's our zombie prefab. Now our empty list, the cool thing we can do is we can just select all our spawn points. Oh wait, hang on first. Remember to lock at the top right. So that locks this inspector window like this. So now I can click on these and it doesn't change. Now I can select all 3 of my spawn points. Oh, no, not like that. All 3 of my spawn points. Click, drag it into spawn points. And then it adds all of them automatically. Just a quick way of doing things. And now if I hit play, there's all our zombies spawned in. So we can go and shoot them and kill them. Oh, and we also had some spawn behind us as well over there. So here's our zombies. So if we go 1. Oh, right, hang on. Let me just make this quicker for speeding things up. Where's our player stats? Unawake. So we have our player health. So we want 10 movement speed. And then we want to basically just do 100 damage when we shoot, just to speed things up a little bit. Click OK. Where they spawn? Oh, we got some over here. So if we click, uh-oh, what happened? But they can hurt me. So why can't I hurt them? Whoop. Time for some debugging. Zombie died. Does this get called? Hang on. Ah, yes, the zombie is never being told to die. Zombie dot zombie controller. Yeah, zombie controller doesn't tell itself to die. Zombie is never being told to die. Kind of important. So in our wave controller, when the zombie does die, we destroy that zombie object. Zombie die event raise. Raise the zombie die event. This is listening for it. When it hears it, it calls zombie died, zombie died, removes the zombie from the list, and then deletes the zombie. That's all fine and good. Are you being called? Debug.log. Just why not? I have a feeling I know what the error is, and it might be a stupid error. Yep, that might be it. Our zombies themselves, I don't think. Let's open the prefab, double check, make sure they don't have box colliders, make sure only this zombie itself has the capsule collider. The target is null, that's fine. So my guess is that when we are actually attacking the zombie, when the player shoots the zombie, so that's in the gun controller, this isn't being triggered. This is my theory, so I probably spelled the zombie wrong. ZOMBIE, ZOMBIE, I know I spelled that right. Click play. Oh, hang on, I need to get out of the prefab so I can see where they are. Yep, you see it's not being triggered. Cool. So why aren't you being triggered? Are you being triggered here, or are you being triggered here, or are you being triggered here? We can just check very easily. Bear with me 1 minute. Okay, so all three of them triggered. So that one triggered that time, that one triggered that time, and that one triggered that time. So you can see when I'm going into Unity, I can double click this one, and then it takes me to the exact line. So I know we hit a zombie there. So we should have killed the zombie. Hang on, let me save that one. I want zombie died there. And then wave controller as well. Here zombie died, just to make sure everything's being called. Rebuild, that's interesting. It's interesting that it worked that time. Okay, so it looks like it's not calling. Yeah, because this one triggered, but it's not calling the player attacked zombie. Because in the combat... oh, zombie died. Whoops, that's in the wrong place. Player attacked zombie. Zombie controller, zombie take damage. This might be the problem. Zombie died event raised. Okay, yes. So when the zombie... zombie take damage, when zombie take damage gets called. What is calling zombie take damage? Zombie take damage amount, player attacked zombie. So this might not be getting called. But if that's not getting called, then... Where'd it go? So this is getting called. Probably the problem is the communication between the gun and the zombie side of things. So the player attack zombie, probably this, zombie take damage. Zombie take damage amount. Stats.take damage amount if stats.health is greater less than or equal to 0. Yep. Okay, that's probably where the communication problem is breaking down. You see, like this is the one downside about this, and why you want to be extra careful is that it doesn't give errors because it's essentially just sending data across. It's just broadcasting information. So you want to be careful because it doesn't actually tell you something is broken. Because it's technically not. It's working fine. It's doing what it's doing what it's supposed to be doing, and that's working independently of everything else, which is why it's not breaking. Zombie controller is zombie controller player attacks zombie. Okay, this is being passed, so this must be true. Zombie take damage. We got a zombie. Zombie take damage. Are you being called? You are being called, yes. Okay, you are being called. This is very annoying. Zombie control. Notes. Zombie died. Let's dot transform. That's fine. Okay, wave controller. Zombies in current wave. Remove the current zombie from the current wave. Destroy zombie.game object. Spawn wave. Add that to the current one. Oh, right, we can probably do some cleanup here just to make things a little... g.transform.parent. So what I can do is I can clean... I'm just cleaning things up. This.transform. So what I just did there was I made it so that the zombies would actually spawn inside this folder by setting this folder as the zombie's parent when I create them. Spawn wave is working fine. It's not spawn wave isn't the problem. Zombie died event raised. Is zombie died event raised being called? Oh, forgot to save that. So that goes here. Zombie has taken damage. Okay, fine. Debug.log. Tell me the current zombie's health. When it does take damage, there might be a problem where I'm causing some code to break. $100. Okay. Also, I'm not able to fire multiple times, so there's a few bugs. The zombie's health is being set to 100, which means the damage incoming from this is no damage is actually incoming. So if I check the damage amount, this might be null. $10. Okay. The player's health. Oh, that's the attack speed. Ah, no, I am stupid. That's also why I can't attack again. It's like my attack rate is once every 100 seconds. So that also might be why my attack... There we go. Okay. Problem solved. There was no problem at all. So now, as I walk around, I can kill the zombies. See, I can click, and then all the zombies are dead. Okay, I knew it was something really stupid, but you can also see now that the zombies are now inside the zombie folder. So if I hide the zombies, I can hide all of them. I can make it compressed. I can keep my hierarchy very clean and tidy. So the last thing we need to do is we need to, as we've been going for 2 hours already, I'm running out of time a little bit. The last thing we have to do is we have to make the new wave spawn. So to do that, kind of easy. We've already written all the code for it. Come on, update. Oh no, because we already have an update. Oh, and I'm working in player. Whoops. That's why. Update. So what we need to do is we need to check in update if the zombies in current wave dot count is less than or equal to 0, and just less than or equal to for peace of mind for me. Then what we're going to do is we are going to spawn wave. We're going to spawn a new wave, mathf.round to int, because remember, we can only spawn an integer number of zombies. So we do it based off of the first wave. So yeah, that was right. First wave zombie count multiplied by the wave's difficulty multiplier. Wave's difficulty multiplier. Okay, and actually I do need these. Okay, formatting sucks. There we go. It's multiplied by the wave difficulty multiplier. Then what we're going to do is we're going to increase the wave difficulty multiplier by plus equals 0.12f. Okay, so the first time it's going to be 20%, then 40%. So over time, the amount of zombies should increase, and then what we can do is we can do debug.log. No, not log error. Log spawned plus number of zombies. Come on. Zombies in current wave dot count. Okay. Debug.log. Why are you unhappy? Log. Capital L for log. Okay. So now what it should do is once we've killed all the enemies in the wave, And if I expand this, you can see, so we've got 5, 1, 2, 3, 4, 5 enemies at the moment. So if I go around and kill them, you can see they're being removed from the hierarchy. So we've got one left, he's over here. Snipe his head if we can. There we go, so now we spawn more. 1, 2, 3, 4, 5, 6. We've got 6 zombies this time. So next time there should be a lot more being spawned, and you guys can play around with this value and everything like that. Just like try to find the game, try to find something to your liking. We click again, so we got 1, 2, 3, 4, 7 this time. We've got 8 this time, so it seems like the zombies are increasing by 1 each time, which is fine. They are spawning only from these 2 sides, so... Oh, right, I made a slight mistake. The random.range, this number is exclusive. Or should be exclusive, I believe. So the count is 3, which means it's working with 2, and it's already 0 because it's working with a list. So you have an index of 0 for the first position, 1 for the second position. So that's like that. Now some should start being spawned on the other side, hopefully. There we go. So now we've got some spawning behind this wall as well at spawn point 3. So I can go and kill these. No particle effects or anything like that. I ran out of time for that, unfortunately. I might make just a video and post it next week. Just some cleanup, some improvements. Last thing we have to do is it'll be nice if we had like a score or something like that for our player. So let's just quickly set that up. So we go back to our canvas, if everybody remembers this. Create empty, so this one's going to be a score. Change it to 2D view, hit F to bring it to the full size, scale the entire thing up so that it fits our whole screen. Then what we can do is we can take our score, drag it to the size we want, create a new image, then we can expand it. Our image we're just going to set to black. Inside image, we're going to create a new UI text, score. Which that will expand here. Then we are going to set the positions to middle, set the color of the text to white so we can see it, increase the font size to big, and then this is like, so in the text we're going to write 9999999 for the score. Don't hit space. Then what we're going to do is we are going to, as well as score, we're going to have wave number, so UI. Actually, no, we're going to have a new empty scale to big. And like you see, once you get going with this, you can get quite quick with putting things together. Wave count. Wave count is going to be over here at the bottom. Then what we're going to do is UI image. UI image is going to expand. And then just like before, so what I can do is I want all like my background images to be the same color. So I can click all of them. So this, the score image, the wave count image, I can click here. I can set them all to the same color just to make them all uniform. UI text, and this is going to be wave number. And then this is like wave 99. Make it centered, scale, wave 99, and we can do the same with our text, so we can click our wave number and our score, set them both the same color white, so that they're all uniform, and then if we want, like, because score is looking a bit tall, so we can shrink score down a bit. Cool. Now let's actually get these set up. So we're going to go into our script. Well, this is related to our player. So our player, we already have a player UI controller. Oh right, we never switched the player UI over to the new system. So let's quickly do that. So what we're going to do is we're going to take damage. we're not going to be... No, combat channel listener, player take damage. Oh, we did. Okay, so we did swap this around. And if I remember correctly, the player... Yes, you just read the player's... Player on damage taken. Player on damage taken. So when player on damage taken gets invoked, that is in the stat screen. We don't want to invoke from stat screen anymore. We want the UI. So instead of the player stats on damage taken, we don't need wave anymore. We don't need the gun. We don't need the zombie. Okay, cool. So what we're going to do is we are going to piggyback off of the zombie attacked player. So when the zombie attacked player invokes, so zombie attacked player, and then this is the cool thing now. So we can quickly update our listener here. All we need to do is provide it a reference to our serialized field, private, combat, channel. We need to just provide it a reference. Then what we can do is we can do simply combat channel dot zombie attacked event raised. You are okay, so you are expecting a float, a little bit, not the best idea to do it that way, where we just have it still pass in the value but then not use it, because that's a little bit of wasted space. But at the moment, let's keep it like that. So the health bar, we're just rereading the player stat health bar. Yep, no change there. We just want to copy this for the on disabled part of things. Remember, like we couldn't use the on enabled because of a bug, but I think what we can do is we can give it a try again, just in case. Let's comment that out and see if our game runs. Nope, so we're still having that problem. Oh, no, hang on, because now what we need to do is we need health bar. No. Canvas. Where is it? Player. Where is the UI component stored? It is stored on the health bar. Okay, not too ideal, because now we're going to be grabbing references to other things, but we could move that away later. Essentially, we're going with quick solutions here due to time constraints. So if we go over to the zombie hits us. Yep, zombies are doing damage to us. Perfect. So our system's completely changed over. Everything is working perfectly fine, just that small change. And now, if you can think about it, it's almost like a star network where you have the combat channel in the middle, everything is branching around it. And data is being sent from and to things, but it's only being sent to the star network, the hub in the middle of the star network, and that is then sending the data out to the other things. It doesn't care about what computers are on the network. So we need to update the score whenever a zombie is killed. So we're going to add another listener here. So if we go back here, player attacked raised, no, zombie died event. So when a zombie does die, combat channel dot zombie died event, we want, no, not on the player. We're actually done with the player. We're just purely on the UI component now. So we do combat channel dot zombie play, and then we plus equals. So we need a new private add score. We can make one where it's like an amount, but for now we'll just leave it the same. We'll just leave it as a flat value. We need to add the score, and then we'll also need to add one private void new wave. Okay, new wave add score. So when the zombie dies, the zombie is going to raise the event, pass in a zombie. Okay, no problem. We're going to run into a problem like that because I'm just piggybacking. So we want to do a, no, we don't want that. We just want that. Now this is probably going to throw a little fit. What do you mean no score? Matches delegate. Yeah, okay, so we're not matching the delegate, so we want transform T because I'm just naming it T because we don't care about it. We will need to create a new one of these for when a new wave happens. New wave. We can, if we really wanted to, make just a generic one for like zombie died, zombie died, oh, what can we name it? We could have like increase score. Okay, we can have increase score and new wave event raised. Okay, so we can have these over here. So when zombie dies, we can also invoke the increased score. Okay, we will have to make a new one of these, however, for the new wave, I'm afraid, new wave. Cool, and then what we're going to do is we're going to raise the event new wave. We don't have to pass it anything. So now when a new wave happens, so we're not listening for the zombie died event, we're listening for the increased score. And then we can add this, and then also don't forget we need to add this to the removal. We don't need the transform anymore. You see how quick it is just to make changes? And then this will affect everything across your code immediately. It's so good. Add score. So what we want to do is we just want to, for the UI, we just want to keep things simple. Private score, private float score equals 0 to begin with. Then we want score plus equals 10 for zombie kill, and then we want private float wave equals 1 to begin with. We can make this, we can get this to reference, but I'm trying to rush now. I am trying to get things rushed now, so we can do wave, nope, come on, wave plus plus. Yeah, there are way better ways of doing what I'm doing, like how we've been doing it throughout. I'm just purely doing it like this, so we can just hurry up on time because we're already running 20 minutes over. So this is just simplicity and speed. This is get it work first. So the score, we're adding 10, we're incrementing the wave plus 1. This is completely disconnected of what's happening in the game. That, in this case, that's a bad thing, because what can happen is we might have a false trigger on the wave, and the wave isn't actually representing the actual wave from the wave controller. Ideally, what you would want to do is you would want the wave controller to tell this wave UI how much, or like what wave you're on. Yeah, but we need to get this done very quickly, so I'm making shortcuts which are bad. So when the wave controller gets called, so we also add another increment, another one here. No, combat channel dot new wave event raised plus equals new wave. Come on, can I please type? Thank you. What am I even doing? That doesn't belong there. Oh dear. So when new wave gets called, we can actually float amount. We can pass it the new wave, and then in here, so we can pass it the wave. Actually, yeah, number. Let's do it this way. It's better. It's in line with what I've been showing you guys the whole session. So new wave is going to take in a float wave number. Wave equals wave number. You need to be of type float so that you match There we go, all good. Cool. So I actually need to open the wave controller. So on zombie, we have wave controller. And I can just click here to show me where it is, and if I keep clicking, it'll open it. So we need the combat controller, and then we need to call the wave. So when the new wave ends, spawn count, we can do channel dot new wave, and then we can pass it wave number, which I just realized we're not actually incrementing, wave number plus plus. So now we'll increment the wave number and then pass it the wave number. Cool. And then when we kill a zombie, we are invoking the score event, increase score event, which is then going to the UI, and then it's going to update this. So for the UI, we need some references to the text using unity.ui. I believe that'll give me access to the text. Serialized field, private text, wave number text. You kind of want to keep things in this kind of format. So if it's text, you put text on the end there, just so when you look at things at a glance, you know what you're doing. Since these are both text, we are going to put them next to each other. So we're going to go score, not capital, score text. Okay, and then wave number text, we are going to do this equals wave number, wave plus wave number text, dot text, so we get the actual text value. What's wrong? Text dot toString. What is wrong? And we're going to type string to unity UI text.string. Oh, no. Text.text equals the string wave plus wave, which I should really I don't actually need, because I'm just being told what the wave number is. So wave can go away. And then similar thing for the score. Score plus equals 10. I need score plus equals 10. Score text.text equals score. Cool. And then on enabled, we are going to just set the score.text, because we need to set it to its default at the beginning, equals score 0, and then wave we need to set to wave 1. The reason why is wave and score are only being updated when either the wave is finished or we kill a zombie. So in the beginning it'll get set to these default values. So we're just going to set wave and score to be their default values to begin with. And we're doing that on the enable just to refresh things if we turn things on and off again. Because otherwise, this is only getting called when we've killed a zombie or when like the wave increases. Okay, this should fix things. Break things, hooray. What is wrong? Oh, right, yes, we don't actually have references to wave number or text. Not to worry, not too difficult to fix. Like I said, don't keep it on the health bar, that's a very bad place to put that. We want wave number and we want score. Oh. There we go, so we're on wave 1 and our score is 0. So if I go over and I kill a zombie, boop, we have a score of 10. Now if I kill all of them, so 30. Where's the rest? There they are. 40, 50. Wave 2. Now we're on wave 2. And we can keep going. And now we officially have a game, although technically I think by definition it's not a game because we can't lose, because there's no code to stop us. If we run out of health, there's no code to end the game. Which we can actually quickly add. Yeah, let's just, I've run over this far, I might as well. What we can do, canvas, we add a new empty game over screen, which we're going to just expand to the full amount. Then in here, we're going to add a new text, actually image. The image will just expand to the full amount. I'll show you how to do a game over, like a faded black background. Game over text. Also, I'm just kind of having fun at this point. I'm kind of just playing around. So we do like slightly gray, drop the black, drop the alpha. Like that. And then the game over text, we just expand to the full amount. Middle. And then we can make it like just red. Game over. Ideally, what we would want to do then is we would want to just call Unity's exit and take control away from the player, but that's going to require some refactoring of other things. So for right now, we'll just do a shitty little game over. For the UI controller, we just want to reference to the game over screen. Serialized field, private, transform game over screen. The game over screen, once again, really not a good idea to have this on the health bar. But I would need to... actually, will this work? So can I just paste it straight onto the canvas? Boop. Actually, yeah, that worked. Okay, let's remove it from the health bar because that really should not be there. And I just pasted it straight onto the canvas. Or I thought I did. Canvas, is it there? Player controller script, health bar, move, canvas. Yes, it's there. Perfect. This is the game over screen, so we're just going to drag game over here. By default, game over is going to be disabled. And then in the... So we can add a new event here. This will just actually, let me do that because I might be able to fix things. Game over. Game over event raised. And like this is I'm just once again demonstrating how good doing it this way is, because it's like, oh, I need a game over screen, but I would need to change so much code. I would need to change so much code in order to, like, I'd have to add references to things, I'd have to make sure players stop moving when they're told. But no, I can literally just go in, add a new, like this is branching a little bit more into like a global manager instead of a combat manager, like probably a better idea to split this. But what I can do is I can just add this game over here, and then like on parts that I need, so like here if we need the stats, actually better if I do it on the player, because we might actually end up running into a situation where if a zombie dies it might call a game over and we don't want that. Oh, also we can remove these. We can remove that debug. Always a good idea to remove as many debugs as possible when you have like your full game. They do take up a lot of processing power. Cool. So now what you want to do is... Yeah, now what you want to do is we want to... I mean, this is kind of just switch to live coding at this point. Actually, it's kind of been for the last half hour. Anyway, it doesn't matter. So when the game over happens, we want the player, not wave controller, we want the player itself. We want the player to invoke it. So we have the combat channel. So we want if our health is less than or equal to 0, player take damage. If player stats dot health, not max health, health is less than or equal to 0, then what we want to do is we want to invoke combat channel dot game over. We want to call game. We want to tell our combat channel that you need to raise the game over flag. Then the zombie controllers will be listening for that. So we need on enabled. And then because the zombies do get destroyed, we need on disabled. We need on destroyed and on disabled. Yeah, because the zombies are getting destroyed, so we will be running into memory leaks there. So we need to listen for the on game over event flag, and then if that happens, private void game over. If game over, we want to add a boolean, a private boolean. We're going to call this game over flag, or game state. Just to like break it up a bit. So in the beginning we're going to be true. Plus equals game over. Okay, we want to put this here, set this to minus, as well as here. We want this to be minus as well. Just to prevent many memory leaks, because we are destroying the zombie controller. And then we want the movement. We want the move to target, and we want everything here. Everything in update. If the game state, if the game play state, if the game is still playing, then we want you to do all this. If the game is not playing, stop. And then we're going to also repeat this for the player controller. Yeah, we also want to repeat this for the player controller. Oh no, you have on enabled, sweet. Okay, go down here, private void game over. So if it's game over, we want to basically, it's the same code. Ideally, you would have a game state manager, which would interfere with all of this. But that would take a little bit of time to implement, so we'll just do the non-efficient way. But if you had more time, you could use a combat controller to manage inputs from the player, and then also that would stop the game from playing. You would have like an overall manager, or what you could even do is you could even do like if you go to that route where you have a manager for movement, input, player, enemy movement, you can also start playing around with time itself, so you can do like bullet time and stuff. Did I paste that in? Yeah, game state. And this is one of the benefits of keeping your update nice and clean. So if play state, then we can move around and stuff like that. If not, game play state equals false. I don't think I did that for the zombie controller on the game over. Game play state equals false. last but not least, we need to have this on the UI controller as well. So you can see our UI controller is taking on a lot of weight at the moment. We're going to make this work with private void game over. And then if game over is called, we want the game over screen dot set active, no, dot enabled, no? Oh wait, hang on, which one is this? I'm saving it as a transform. Dot game object dot set active, there we go. Dot true. And then, so yeah, now if my health hits 0, if I've done everything correct, it should lock my controls so I can't move. The zombie should stop moving as well. The zombie should stop moving and it should flash the game over. There you go. And now we have a game over. So the game can officially end. And now, technically, by definition, we have a game. Unfortunately, there's no way to start it again. So, with all this, let us build it. So we can do build settings. You go to File, Build Settings. We want to build for PC, Mac, Linux standalone. You can also build for like iOS, PS5, tvOS. You can build for lots of things. We want to add the open scene. So this is the open scene is the scene we currently have selected. Otherwise, there's going to be nothing in our game. Pretty much just leave everything else. Yeah, x84, x86, and 64-bit architecture. So if you want 32-bit, I only have the Windows platform installed, so you can just only build for Windows. Compression method, just default, don't care. And then we can do build and run. And then it's going to tell us to select a location so we can make a new folder. So this is inside our project folder. So we're going to do build and run. Might take a little bit. Here we go. Oh, it opened on my other screen. Whoops. Let me... Oh, hang on. There are going to be zombies coming for me. I need to switch screens very quickly. Oh, that's the wrong one. That's my notes. Here you go. So now you can see we have it fully built in full screen, and I can kill the zombies. Yep, and now we're on wave 2. Kill more zombies, and they'll just follow around. And you can make this world look however you want. You can make the world look however you want. By about tomorrow afternoon, tomorrow evening, I should have this uploaded to a GitHub page, which I will post in the group chat. Or I'll give to Benjamin to post in the group chat. I don't exactly know where he wants it. And then people can just take this code and run with it. I'll add a lot more comments, explain a lot more in text. And yeah. Thank you guys very much for joining me on this little process. I hope you guys learned some stuff. I hope I showed you some new things about Unity, some like really cool features. And yeah, let's have a game over, just so I can get my mouse back. Oh, yeah. You see now escape doesn't actually give me my mouse back. You have to, because we never programmed in a escape menu. So we'll just game over it. And you can see now the whole world stopped moving. And yeah, so thank you guys for watching. Oh, hang on, the new zombies that spawned aren't. Oh, because when they're created... Oh no, I still have health. Never mind. Bugs. I'll fix bugs. Don't worry. Okay. Well,